to explain the Pregel algorithm in detail. How does it perform parallel graph processing, right? So the Pregel algorithm is a parallel graph processing algorithm that allows for efficient computation. It operates in a series of super steps where each super step consists of 3 phases: computation, message sending, and message receiving. During the computation phase, each node applies a user-defined function to update its state based on the current state and the messages received in the previous super step. The updated state is then sent as messages to its neighboring nodes during the message sending phase. In the message receiving phase, each node receives messages from its neighbors and stores them for the next super step. All right, so here we can see kind of an implementation of this. It's implemented using nodes and channels, so each node can receive and send messages. And channels represent the communication channels between nodes and facilitate the exchange of messages. So here you can see it's creating a Pregel application with a node and a channel, and it has this input and output channel. And then you create a graph, add the node, set an entry point and a finish point, and then you compile the graph. Then you can invoke it. In this example, the Pregel application consists of a single node and input and output value. Okay, so from now, let's try to decompose the role of nodes and channels in the implementation of the Pregel algorithm. The nodes represent the computation units or processing units. Each node performs a specific computation, and channels allow nodes to send and receive data or messages from the other nodes. The Langgraph library handles data transformations between nodes using each of these components, right? So there's the channel, which passes data, a topic, and context. So topic allows data to be published to a specific topic and subscribed to by other nodes. And you can have multiple nodes listening to the same topic. Last value is the channel stores and passes it to the next node. And context. This channel allows the sharing of context data between nodes. The Pregel read and write stages, how are they different and what does each stage do specifically? So the read stage is responsible for reading the data from input channels. And then the write stage is responsible for writing data to output channels. It takes the output of the computation and writes it to the specified output channel. And it's often used to store the results of computation or pass data to the next stage of the computation graph. So here we can look at some actual pseudocode of how this works, right? So as you can see, you can have each of these nodes. You have 2 nodes, 1 and 2, and then it subscribes to input and it writes to output. And again, you have another 2 subscribes to input, writes to output. And then here you essentially create a Pregel app with that graph. All right, so now you can see this is the state graph. The state graph is the representation of the graph. So it has a node, an add an edge, set entry point, finish point, and compile. So this is what this graph representation ultimately has. And you can run set graph. Yeah, so once you create a graph, you can add each of these. And then you call app.invoke. And yeah, it takes in what you asked for. Now let's look more into what exactly the memory saver is doing, topics, channels, how they're different from each other. So a memory saver class is a subclass of the base checkpoint saver, and it's defined essentially using this config specs, and it stores the representation at a given point in time so that you can checkpoint your agent's execution. The Pregel framework utilizes the memory and memory saver classes for saving and retrieving checkpoints during the execution of the Pregel computation. It is responsible for storing and retrieving checkpoints during the execution. And here's an example, right? So you define the memory and then you have a saver, and that takes this memory. In this example, the memory class is instantiated and passed the saver argument to the Pregel constructor. This allows the Pregel framework to save and retrieve checkpoints using the memory class. The memory saver class is a subclass of base checkpoint saver and provides an implementation for saving and retrieving checkpoints using an in-memory storage mechanism. Great, so now let's try to understand better how this memory saver, topics, and channels, how are they all related, right? So we understood that memory saver is a checkpointing mechanism. Topics are channels that allow multiple subscribers to receive updates from a single publisher. And channels are communication channels between nodes in a graph. And they can be used to subscribe to topics, perform operations on data, and write data to other channels. So we can have, channels can have different types, such as topic channels for publishing and subscribing to topics, and context channels for passing context information, and last value channels for storing and retrieving the last value written to the channel. So here you can see pseudocode for a topic. It allows you to update, get, and checkpoint. Yeah, and if you want to write and read from a channel, you can do channel.write_to, channel.subscribe_to. There's a few key differences between topics and context. There are different value and update types. Topic channels accumulate updates, context channels do not accumulate. Topic channels can be set to enforce uniqueness, so there's no duplicate values, while context channels do not have that feature. Checkpointing, topic channels can be checkpointed, context channels cannot. Topic channels can be used as input or output in a Pregel computation, but context channels are only used as input. Great, now there's a lot more you can continue to ask to understand, the diagram of the chat agent executor, how is the agent state represented, and then we can also look into each of these examples, how it's set up using the Pregel class from the Langgraph library, as a drafter, editor, reviser, each of these different chains determines what's the input, the output, and how the channel handles writing it. Okay, great. Hope you have a good understanding of Langgraph.